Hello students, welcome back. Let's resume section 2, product and quotient rules. Previously we went through these rules, the product rule and the quotient rule. Now let's discuss the generalized product rule. Here we had just two factors, u times v. Then we end up with two bunches added up with u prime v plus uv prime. And each bunch has only one derivative, u prime here and v prime there. Likewise, if we have three factors, then you're going to get something like this. U times v times w, we have three factors, so we need three bunches added, and each bunch has only one derivative, u prime, v prime, and w prime. Now what if you have four bunches? Kind of like this. Then this will be zx there, and then zx will be there, and then there we have zx. And then this one will be just w of x, and the final expression here, that's going to be the derivative. Like this. So we have four bunches added, and each bunch has only one derivative, u prime, v prime, w prime, z prime, like this. And 5, 6, 7, or any arbitrary, you can do it like this. That's the way the generalized product rule works. Now up to 3, you see quite often. 4 or 5, very, very rare. We have 3-factor problem here and another 3-factor problem here, and this one is 4-factor problem, and this one is really, really rare. As for 3-factor problems, I think you should know how to do this. So how do we handle that? Let's copy and paste this. Like this. Now from the first, we need one derivative, and this is the one. So we have the derivative of 1 plus exponential x. So this derivative is e to the x power. And then the others remain the same. Now for the second one, this should be the derivative, right? And what's the derivative? Derivative of x is 1 minus derivative of this, that is x to the negative 1/2 power. You see, 2 times 1/2 power collide, and then we have just 1, and that's the derivative. And finally this one. There you go. We have 3 bunches added, and the derivative like this. Here's the answer key. Now how about this one? At first glance it looks like 4 multiplication, but actually there are only 3, because x times square root of x, you can combine those into a single power function, x to the 3/2 power. Turns out like this. You can write like this, and then you can apply the generalized product rule here. 3 bunches, and first derivative, the second derivative, third derivative, like this. And then you can simplify if you want to. Is that clear? Maybe not. I'll close it and try to do it on your own. How about the last problem here? Well, this is going to be a major pain in the rear end if you write down everything, because this is going to be really long, because we have 4 factors to consider. So we have 4 bunches added up, and each of them has only one derivative. But it's not going to be too bad with computer because I can always use copying and pasting. So first, and the second, and third, and fourth, like this. And then this will have to become the derivative, right? So what's the derivative computation here? 3x squared plus e to the x power, right? That's the derivative computation of the first factor, this one. Now, it should be the second factor that I have to work out now. So what do I put in here? 2x plus 3 over 2x to the negative 1/2 power, because this is positive 1/2 power. And this is minus minus plus x to the negative second power. This negative 1 power is multiplied, so it becomes positive. So this is a derivative function. And then now we have to work out this one. So this one is x to the negative 1/2 power function. So negative 3/2 and then negative 3/2 power, because I subtracted 1, plus 1 over x power. And that's the derivative. And then finally, I have to take care of this part. So this is 2 e to the x power, which stays the same, minus 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 plus 5 times 3, so 15x to the negative 4th power. Did I do this right? Well, I did the individual derivative computation rather quickly. And maybe it would have been better if I converted all these into power forms first. Yeah, that would have been a bit easier. Taking the derivative, I'm going to get this red. Taking this derivative, I'm going to get this red. Taking this derivative, I'm going to get this red. And taking this derivative, I'm going to get this red. Writing everything down in paper, that's not going to be a fun job to do, but with copying and pasting with computer, you can handle it. Even if you have 5 factors, 6 factors, not too bad. Here's the answer key, by the way. Okay, so much for section 2. Remember, product rule, quotient rule, and the generalized product rule up to about 3 factors.